Hello, everybody. Good morning, good afternoon, good evening, wherever you happen to be. I hope you are doing well. Welcome to the first ever PlatformCon. My name is Jonathan Rao, and I am the CISO, the Chief Information Security Officer at Lightspin, a cloud native application protection platform tool. And I'm here to talk to you about why we, the Lightspin office of the CISO, developed our own Amazon EKS infrastructure as code IaC tool, how we use it for our platform tech, and how security could actually be a business enabler by creating tools like that increase developer productivity, that help you actually build out your platform securely from day one, so you don't have to deal with any bolt-ons. And I'm going to share a short presentation, so bear with me for one moment while I get that up. And blank screen, we're good to go. So, quick agenda: who or what is a Lightspin? What's a Lightspin, right? Lightspin's EKS creation engine, or what I'll refer to as ECE throughout. How we use ECE for our platform tech, and what the day in the life of platform engineering is like at Lightspin, and how the Office of the CISO helps be a security enabler, and why baking in versus bolting on or trying to shift security left is folly. Controversial take to get started. So, Lightspin. Founded in 2020, Israeli based, but there is a US team, obviously. I'm based out of New Jersey. We're a cloud security software as a service company, and our niche area is that we are a graph based CNAPP. And CNAPP is Cloud Native Application Protection Platform. It's kind of an amalgamation, not really so much a single pane of glass, but imagine a tool built from the ground up with all the multiple capability sets within it. So think things like cloud native vulnerability management, dealing with the elasticity, new EC2 instances and Lambda functions and containers and bits of code and data. Everything's everywhere, so it does all those things that we know and love: CSPM, continuous compliance monitoring, benchmarking, vuln management, threat intelligence, cloud infrastructure and entitlement management, CIEM, right? Not to be confused with an actual SIM. We don't do that, right? We're not a log aggregation tool. So that's what a CNAPP is. But like I mentioned, our niche is that we're built from the ground up on a stateful property graph database. Every customer gets their own graph, and then we're ingesting all their assets, all their security findings, threat intelligence, sentiment analysis, OSINT, the latest and greatest in R&D, tradecraft, all their CVEs, all their CVSS scoring. All of that stuff will get baked into the graph, and our algorithms and machine learning team, patent pending, have developed ways to be able to extract the attack paths that identify the multitude of vectors, what findings, what vulnerabilities contributed to them, and how you could remediate them. Sometimes we provide the remediation, and sometimes we just give instructions on, where to attack the kill chain to collapse that attack path down. So, think that you get dozens of findings versus of tens of thousands, depending on the size. We support all three of the major CSPs: AWS, Azure, Google Cloud. We support Kubernetes running anywhere, as long as it's, K8s compatible, depending on the version. And we're built on the AWS cloud using Kubernetes now. Day-to-day and platform engineering at Lightspin is, very focused on GitOps and IaC. It's required a transition. We've brought in a ton of engineering staff. We've grown post-Series A. We've been capturing more customers, expanding the platform, adding more capability sets into that CNAPP concept. So that means that our platform has to pass muster, be able to scale, right, with all the different tenants on it, even getting to some more, single tenant design in a multi-tenant environment, to build in resiliency, to build in scale, to build in elasticity, to help optimize costs and help to optimize the developer experience overall. We have people from all sorts of walks of life, both on the Israeli side and the US side, and other teams around the world that help. Both from consulting and full-time. And not everybody's on an even playing field when it comes to the tech. And we made the decision to go with Kubernetes, AWS EKS in specific, to be able to rapidly deploy, to orchestrate these containers, to be able to turn our what makes up the platform, the dozens of microservices within it, to be able to roll it out, quickly iterate on it, use feature flags, have specific functions and things turned on for specific tenants, specific customers, right? So there's a lot of added complexity when you get into all that. Kubernetes itself is a very complex project. It's even more complex when you move to managed K8s, mostly due to permissioning, right? Like how many permissions you need to give somebody to actually deploy it, how many permissions you have to give, the IAM role that's underneath it, things to access, right? And, when you talk about like privilege escalation, lateral movement, things like that from the security aspect, and things that we do active research and development on. We have a whole security research team led up by Gafanita Amiga, one of my peers here at Lightspin. And then you add the fact that, well, okay, it's hard enough as it is. There's version incompatibilities. There's Kubernetes incompatibilities between AWS EKS and like mainline 1.24 as of the time of this recording, or is it 1.25 beta? Whatever it is. When you have all that together, it's like, how can we make this easy for anybody to use, whether it's a security research, QA, full stack engineering, DevOps engineer, SRE, to be able to, pick up a tool, deploy out Kubernetes, and then, we already have a separate development, GitOps IaC sort of style that we do, other infrastructure builds out, that we, create Helm charts, that we manage secrets and RBAC. How do we take all that best of class stuff and add it into something that's modular, easy, and pluggable, right? So that enters in ECE with, the things in solving for the inherent weaknesses in a managed K8s environment, because there's a lot of security things that are turned off by default in EKS, right? Like secrets envelope encryption, audit logging, log forwarding, even, AWS guard duty Kubernetes protection isn't turned on by default. And then also, quick prototyping and the developer experience. Since we do use IaC, we're using Terraform like a lot of other people, and I find that there's a paradigm shift there that using state-based infrastructure as code almost kind of forces you to start treating your platform as pets and not cattle, where you have the single state, and it's like, okay, do we add more definitions in this, ginormous state file? Do we import more state? Like, how do I just quickly prototype it? Now I have to break off of state, but what if I pull something forward that, maybe there's a secret, maybe there's a parameter, maybe there's something that refers to something upstream. It's a mess. It's like, how can we have something that's self-contained, built to our standards, security baked in by default? And that's what ECE is. So there on the right is kind of our little cheeky graph about default by AWS, default by ECE. From the GitHub repo, and you can find it under EKS Creation Engine. So that's ECE. It's a Python-based CLI. I wrote the thing. I had help, but most of the code is mine, so it's kind of bad, like how classes and stuff are managed. But the idea behind it was that I just want to have a CLI tool, very simple, that anybody could pick up and just like create a cluster. I have a VPC. I want the cluster to go here, and it'll take care of everything for them, right? So I'll have all the logging on. It'll turn off the public API endpoint. It'll turn on the envelope encryption. It'll create a key for that cluster with minimum necessary permissions for the principals who need to have access to it only, the creator and anybody else that you have. It uses IMDS v2 on the nodes. It'll use the KMS key and apply it to launch templates for the EC2 instances. So the nodes themselves are encrypted as well. It'll dynamically, bootstrap custom AMI. So if you want to use, right now it's just Ubuntu and Amazon Linux too, but eventually we'll support Windows and we'll support BottleRocket as well, and then possibly others. So it'll bootstrap them. It'll tag the instances with some just basic intelligence, like who created it, when they created it, why they created it, and then any other tags they want to add. And then also it'll, do things like install Falco Sidekick. So if you want to send logs, if you want to send security findings to SNS, to Lambda, to Datadog, it'll set up Datadog for you. It'll install Microsoft Defender, formerly MDATP, onto the nodes if you want it. You could perform sys benchmarking using Kubebench. You could scan all the unique containers running in your cluster using Trivy. So that was really the idea behind it. And it was super easy to plug into CI systems, the way that it outputs logs, the way that it has wait states. It'll automatically roll itself back if it runs into an error that it can't progress from, just like a CloudFormation. It'll spit out, not really a state file, but it'll give you information about the cluster that you could reuse, recreate. Maybe you ran into a problem with it. Maybe there's incompatibility for some reason because you're running too much stuff on it. And then the way that the plugins are written as well, again, native Python. It tries not to use any external libraries. It does not use the Kubernetes SDK at all. So that's really the point behind it. And it's like, well, why'd you create it? Like there's Terraform, there's Pulumi, there's CloudFormation. None of them, I wanted to get all the cool things from all those different stacks and put it in OCLI because, having to learn one more language, more YAML, more JSON, I don't have time for that. Nobody really has time for that. So, that's kind of why. And it does support the platform tech where any clusters that are getting spun up in dev, QA, UAT, production, pre-prod, if they're getting stood up on my own, right? The Office of the CISO uses EKS for some of our services that we host and we build on our own. We use it for data engineering, sec data ops, more on that in the future. And then also the security research team, it's like, hey, we'll just pull it out. And then, we're also seeing some early traction within the community, not as much as we would like, right? But there's people who are interested who want to use it. We've given webinars on it in the past. We're partnering with some other commercial companies to add their own stuff as plugins into the tool as well. And then we have plans to, expand it as we could free up development resources because it is a busy time for us here at Lightspin. So again, why did we create it? Just a rundown. It's a familiar CLI, and it's easily integrated into our platform engineering workflows, right? You could drop this thing in AWS code build. You could drop this thing in a Jenkins. You could even write it in a sort of a way where, you could create a pipeline. You could create a GitHub action that'll deploy this out, right? We have OADC providers. We don't use secrets or tokens. It's all ephemeral, just in time, limited, minimum necessary access from that GitHub action. Run a GitHub action to create ECE, and then with that cluster information, pass it off to something else. So it's like, hey, deploy the Helm chart that runs Lightspin. Deploy the Helm chart for, security tools or for analytics tools, whether it's EMR and EKS, OpenSearch clusters, you name it, it's just all self-contained. I don't have to worry about, okay, dang, now I need all these permissions to deploy this CloudFormation template. I need all these permissions to deploy, to apply this Terraform state. Oh, wait, CloudFormation has its own kind of IAM principle, and that's what has access. Now I have to find a way to backdoor that and give extra access to the cluster. Now everybody's an admin. Everybody is systems master. I don't want to do that. Security is in there by default. You can't turn it off. It's like, I want to run IMDS v1. Well, you better go into the code base and do it yourself or create it some other way because I won't let you do it. I want to bring in this deprecated OS. Nope, won't let you do that either. I want to, not install. Well, you could actually choose to not install Falco. Some of the plugin stuff I don't force you to do. But this also makes it easier to pass muster where it's like, oh, dang, did I remember to put these 10 things that security wants on? It's like, oh, I just have a couple flags, true, and a URL, and boom, off you go, right? So it fills in that gap nicely where it's not just IaC, it also does the post-deployment activities as well. That Falco, configuring the AWS CLI to actually authenticate, with kubectl into it using the EKS IAM authenticator. It'll, set your logs up. It'll forward them out if you want them to. It'll set up EDR. It'll tag your EDR sensors. And again, extensibility, community driven, right? And like I mentioned before, state managed IaC leads to pets and not cattle. I want cattle. Kubernetes, I want my clusters to be cattle. I just want to deploy them. And if I don't like them anymore, I want to destroy them, right? And this is what ECE enables you to do. And then kind of closing thoughts, right? Security is a business enablement. You hear it a lot too much as DevSecOps approaches, right? Where it's like, oh, we're going to shift security left. And I think it's like a conspiracy, right, by the security industry to kind of push off security responsibilities because security teams are becoming increasingly less technical. And it doesn't help that there's leadership out there in the community who are beating the drums and saying this. And look, I don't care what segment of security you work in, or even if you're outside of security, if you're dealing with platform operations, tech, product, even marketing, you are technical, right? And security you have to be. So this whole shift left mentality, even when you're properly integrated, it's like, oh, I have security people like staff engineers on my development team, or maybe you have a good partnership and you could, I don't know, high five your CISO, your director of cloud security or something like that. It just doesn't scale right. I think it's a great thing to do as an injunction where, let's say you have well-established processes for, enterprise architecture, for platform tech, for deploying things out. And then it's like, oh, crap, we forgot to do security. DevSecOps can't help to at least flush out the obviouses. It's like, okay, let's start scanning IaC. It's like, wow, we have 30 million high findings. Okay, let's start scanning our Terraform files. Let's start scanning the IaC. Let's start, basic, linting, checking out best standards. Let's run Black. Let's run, PyLint and things like that, which aren't necessarily security tools, but, following, strict procedures when it comes to like writing, authoring code, so you could detect changes, code signing, things like that. It's all within this idea, and it becomes bolted on. Now you have to add extra things to your pipelines, add extra findings, right? So look, if you bake it in, if you have those requirements already there where you have a ECE and it deploys out your Kubernetes clusters, if you have similar tools, that'll actually just deploy things out. You're saving a lot of time, a lot of money, and a lot of pain. You include security in the platform from the beginning. And that's it. So thank you, everybody, for your time. It's been great. I've been Jonathan. You've been awesome. Stay dangerous. I'll see you out there in the community.